You missed it. Oh, there we go.
Is it on?
Yes, we're recording.
This is 8.2, the extra practice, the review that I gave you guys. Problem 1, we're finding the inverse tangent of root 3. If we're finding the inverse tangent of root 3, what quadrant are we in? We're in the first quadrant because we're positive. So you know you're in the first quadrant, draw your triangle. Tangent, remember, is opposite over adjacent, so we can put this over an imaginary 1. So from this angle, remember you're always measuring your angle off of the x-axis at the 0 here. So we're looking for this angle. Opposite over adjacent. So what angle is opposite the root 3? So what angle is that?
60. Pi over 3.
So it's a pi over 3. A 60-degree angle.
On video. Who do you think he is?
Alright, number 2. We're finding the arc sine of negative 1/2. What quadrant are we in?
4.
We're in 4 because we're negative. That's a negative ratio, so we're in quadrant 4. So again, measuring off of the x-axis, we have opposite over hypotenuse. So what angle gives us that? Negative what?
Pi over 4.
Negative what?
Pi over 4. 6.
Pi over 6.
Oh, 6.
I said it the first time, and then you guys were like, no. I did.
It's a negative pi over 6.
Mess up.
Remember that this is, guys, this is your 30-degree angle, so that's a
We're
negative
just
pi
passionate
over
about
6.
math. Be happy it's not in the conversation.
Alright, number 3. You're finding the inverse cosine of negative root 2 over 2. What do we need to do to this root 2 over 2? Unrationalize. So we end up with a negative 1 over root 2.
Make it my mother.
So what quadrant are we in for cosine?
2.
We're in quadrant 2. Draw your triangle. Now remember, for cosine, you always start at the 0 for your angle. So we're actually looking for that larger angle. We're going to use the smaller one as our reference angle, but we're actually looking for that one. So cosine, remember, is adjacent over hypotenuse. And make sure that you know when you're in the second quadrant that your x values are negative, so this is a negative 1. So now, what angle gives us this triangle?
3 pi over 4. Well, are you talking about the big one?
Well, our reference,
Oh,
you're
the
right,
one's
our
pi.
reference angle is a pi over 4, but we're looking for the pi over 4 that's in the second quadrant, which, like Jasmine said, is 3 pi over 4. Do not write pi over 4. You're looking for the bigger angle.
True.
So, how do you know that you're looking for the bigger angle instead of this one?
For cosine, if you're in the second quadrant, you're looking for that bigger angle.
Okay.
No. Because you're measuring 0 to pi. So all your angles for cosine are going to be pi. Alright, number 4. The inverse tangent of negative 1. What quadrant are we in? So we're looking for that angle. This is opposite over adjacent. So opposite over adjacent. What angle is that?
Negative pi over 4.
Negative pi over 4. Because that would be a 45, but we've rotated back, so it's a negative.
How many questions did you have?
20 or less.
Can you tell I asked that or anything?
Number 5, we're finding the arc sine of negative 1. A lot of you guys had an issue with this one. If you do this like you normally do, you would have your opposite, which is negative 1, over your hypotenuse, which is 1. Is that any of our triangles? Did any of our triangles have a hypotenuse of 1?
No.
Yes.
For like number 4, I thought the inverse tangent could only be in 1 or 2.
No, the inverse of tangent is in 1 and 4. It's just like the sine.
Well, this is wrong.
Cosine is in
This says you will be in quadrants 1 or 2 only.
You missed my correction, I had you guys correct it when we went over the notes. It should say 1 and
Ellipses,
4.
dot.
Sorry.
Wait, so sine and tangent are in one?
Sine and tangent are in 1 and 4.
Cosine's in one, too.
Cosine is in 1 and 2.
Can you tell me both me?
Sine and tangent, 1 and 4, cosine.
Alright,
No, I'm writing it down so I have to repeat it. You guys are so annoying.
so, number 5. We're finding the arc sine of -1. So like we just said, none of our triangles have a hypotenuse of 1. So we have to go back to figuring out when we were talking about the unit circle and sine. We redefine sine as y over r. So this is where we have to think y over r. Our r is always 1, so we're looking for where y is -1. So where on our coordinate plane is y equal to -1?
Negative pi over 2.
Right here is 0, -1, and that is negative pi over 2. If we rotate back, it's negative pi over 2. Alright. Similarly for 6, we're taking the inverse cosine of 0. So we're looking now at how we define cosine. And what did we define cosine as? X over r. So now we're looking at our coordinate plane. Where is our x equal to 0? And remember, you're looking for where your x is equal to 0 in the quadrants that we consider for the inverse cosine.
Pi over 2.
So it's 0 here at 0, 1. Now it also is 0 down here, but we don't pay attention to 3 and 4. So we're only looking there, and that's at pi over 2. Is everybody okay with 5 and 6? Okay, now we're going to get into the composites. Remember, for the composites, you do what's on the inside first, and you put that into the outside. So for number 7, we're taking the cosine of 3 pi over 2 first. So where is 3 pi over 2?
0, negative 1.
So 3 pi over 2 is right here. And like Jasmine said, that point is 0, -1. So we need to find the cosine at that spot. So what's our cosine? Remember that cosine is y over r,
0. Right?
No.
No,
Cosine's x over
or is
r.
x over r, sorry. Thank you, I appreciate that.
Zero.
So you're paying attention.
So here, it's 0. So this cosine of 3 pi over 2 gives you a 0. So we want to find the inverse cosine of 0. So that goes back. Where is cosine equal to 0?
Pi over 2.
At pi over 2. So we get pi over 2. Number 8, we're taking first the cosine of pi. So pi is over here. And what is that point?
Negative 1, 0.
-1, 0. So what's our cosine at that spot?
Negative 1.
So our cosine is -1. So we want to take the arctan of -1. So we're going to draw another triangle. What quadrant are we in if we're taking the arctan of -1?
4.
We're in 4. Remember that this is opposite over adjacent. We can put that over an imaginary 1. So what angle is that?
Negative pi over 4.
Negative pi over 4. Number 9. We need to find the sine of 7 pi over 6 first. Where is 7 pi over 6? It's in the third quadrant. That's 7 pi over 6. So we're going to use pi over 6 as our reference angle so that we can label our triangle. So if this is pi over 6, what is this side? -1, because we're in the third quadrant. Make sure you're making the proper values negative. It will make a difference. So here your y values are negative, so you have a -1. What's this side? Negative square root of 3. Again, your x values are negative. And then what's our hypotenuse?
2.
So what's the sign of that triangle? So it's -1/2, or 1/2. So we want to find now the arc cosine of -1/2. So we're going to draw another triangle. What quadrant are we in? For
2.
we're in 2.
Too deep.
So this is again adjacent over hypotenuse. But remember again that we're looking for that larger angle.
2 pi.
So that's 2 pi over 3 again. Because we're looking here at the pi over 3. So we're looking at the pi over 3 angle in the second quadrant, which is 2 pi over 3. Is everybody okay with that one?
There's 2 number 8s.
Okay, the next number 8. We're taking the cosine of 2 pi over 3. Where is 2 pi over 3? It's in the second quadrant. So that's 2 pi over 3. So this is a pi over 3 angle that we're using for our reference angle. So how do we label our triangle? What is this side? This is root 3. What's this one? -1. And then our hypotenuse is 2. So what is the cosine of that 2 pi over 3? Adjacent over hypotenuse. So you get -1/2. So we're going to take the inverse sine of -1/2. So again, you want to draw another triangle. What quadrant are we in?
4.
In 4. We're looking for that angle. We have opposite over hypotenuse. What angle is that? Negative pi over 6. Good. So are we noticing that some of these kind of repeat after a while? So. All right, now number 9. We want sine of 3 pi over 2 first. So again, where's 3 pi over 2? 3 pi over 2 is here. What was our point? 0, -1. So what's our sign at that spot? -1. So we're going to take the arctan of -1. So we've already done this one, but we'll do it again. We're in the fourth quadrant, opposite over adjacent. What angle is that? Negative pi over 4. Number 10. We need to find the sine of 11 pi over 6. Where is 11 pi over 6? It's in the fourth quadrant. We're going to use this pi over 6 angle as our reference angle to label our triangle. So we're looking at our 30, 60, 90 triangle. This side is -1. What's our, that's root 3. And what's our hypotenuse?
2.
So what is the sine of that angle? Opposite over hypotenuse. So we get negative 1/2. We're gonna take the arc cosine now of that negative 1/2. I'm gonna draw that triangle over here because I ran out of space. So where is negative 1/2? It's in the second quadrant because it's negative. So we have adjacent over hypotenuse for cosine. And again, for the arc cosine, you measure from your 0 and you're going into the second quadrant. So that's going to be one of those bigger angles. So again, we get 2 pi over 3. Because this is a pi over 3 angle, is our reference angle. So we're looking for the pi over 3 angle in quadrant 2, which is 2 pi over 3. Number 11. We're now taking the inverse sine first. So we're going to get an angle, and then we're going to put that angle into the sine function. So for this one, Kara just said we can use the property. If you don't remember that you can use the property, you can also still draw it out. If we use the property, what do we get? We get root 2 over 2 back. Now, if you weren't sure that this went along with the property, you would draw it out. So we're positive, so we're in the first quadrant. So remember that this is 1 over root 2. So our opposite side and our hypotenuse. So what angle is that? It's a pi over 4. So then we want to take the sine of a pi over 4 angle. And we get opposite over hypotenuse back. So we get that 1 over root 2 back, which is root 2 over 2. The next one, number 12. We're going to take the inverse sine of root 3 over 2. So which quadrant are we in? We're in 1 because we're positive. Sine is opposite over hypotenuse. So this is our opposite side and our hypotenuse. We're looking for that angle. So what angle is this? This is a pi over 3 angle. So we're going to take tangent of that pi over 3 angle. So we need to know our adjacent side now, which is 1, because that completes our 30, 60, 90 triangle. So what is the tangent of this pi over 3 angle? Root 3, opposite over adjacent. So we get just root 3. And then number 13. We're taking the inverse sine of negative 1/2. What quadrant are we in? We're in 4 because it's negative. So we're looking for that angle off of the x-axis. We have opposite over hypotenuse. So we have negative 1 and 2. What angle is that? What is it? Negative pi over 6. So now we want to take the cosine of that negative pi over 6. So again, we need our adjacent side, which is root 3. So what is the cosine of negative pi over 6? Adjacent over hypotenuse, which is root 3 over 2. The majority of your test tomorrow will be questions like that. Now, the next 3, there will be questions like this as well. So make sure that you know how to do these. They look hard, but they are not. Okay. So again, we have a composite. We want to do the inside and put that into the outside. So we're doing the inverse cosine of negative 2 over 3. So if we're taking the inverse cosine of a negative, what quadrant are we in? We're in quadrant 2. So we're going to be over here. So draw your triangle in quadrant 2. Now, remember that cosine is adjacent over hypotenuse. So we're going to label our triangle. Our adjacent side is negative 2 because our x, remember, is negative. And then our hypotenuse is 3. So we're using this reference angle again. Now, this angle, we don't need to find this angle. That angle is just a go-between to get our sine. We actually want to find sine of that angle, whatever this angle happens to be. So in order to do that, what's sine? It's opposite over hypotenuse, right? Well, we don't have our opposite side.
Thank God for Pythagorean.
So we use the Pythagorean theorem to find our third side on our triangle. So we're going to just label that as x right now. So we have x squared plus our other side is negative 2 squared equals 3 squared. So then you're just going to solve for x like you normally would. And you end up getting that x equals square root of 5. So this is square root of 5. So now, can we find the sine of that angle? So it's opposite over hypotenuse, or root 5 over 3. So our answer is root 5 over 3. You don't need to find that angle in order to find the sine of that angle. Does everybody understand that? Number 15 is doing the exact same thing. This time we're taking the arc sine of 3 over 8. So what quadrant are we in for that arc sine? We're in the first quadrant. So draw your triangle. You have opposite over hypotenuse. So opposite over hypotenuse. Again, we can just call that u. So we want to find tangent of u. So we need this side again, so we'll call that x again. And we're doing the same thing, Pythagorean theorem. So we have x squared plus our other side squared equals 8 squared. Solving for x. You're going to get that x equals root 55. So what is the tangent now of that angle?
3 squared is 55 over 10. That's just rational.
So it's opposite over adjacent, so it would be 3 over root 55, but we rationalize. So you're going to end up with 3 root 55 over 55. Is everybody okay with those two? Now, the last one is actually doing the exact same thing, except this time we're not given an actual number. We're given a letter. So our overall answer is going to end up being an algebraic expression. So there are going to be variables in our answer. So we want to find the inverse sine of v. So v we're going to say is positive because there's not a negative in front of it, so we can assume that v is positive. So if we're taking the inverse sine of a positive number, we're in the first quadrant, and we're looking for that angle. Sine is opposite over hypotenuse, so we can put this over an imaginary 1. So we would have opposite over hypotenuse is how you would label your triangle. Now again, that angle does not matter because now we're going to take the cotangent of that angle and get back a ratio. So we can call that U again. Now to find the cotangent, what is the cotangent?
Adjacent over opposite.
Is adjacent over opposite. So we need to find this adjacent side. So we're going to call that x again, and we're going to do the Pythagorean theorem again. We have x squared plus v squared equals 1 squared. Now, remember that you're solving for x. V is what you're given. We're leaving that alone.
Is Brittany here?
So now we're going to solve for x. So x squared equals 1 minus v squared, square root both sides. You get the square root of 1 minus v squared. That's what our x equals. So now, cotangent we said is adjacent over opposite. So what do we get? So we get the square root of 1 minus v squared over b. Adjacent over opposite. So that is our final answer. Is everybody okay with that one?
Yeah, great.
All right. The last four are calculator problems. You're going to simply plug these into your calculator and get the decimal answer out. Make sure that your calculator is in radians. Your calculator must be in radians, otherwise your answer is wrong. So when you plug these in on the Inspire,
Will you do it up there just to make sure? Like,
Yep. So I will remind you how to turn your computer or your calculator, how to turn your calculator to radians. You'll go to settings, document settings, and right here where it says angle, it should say radian. Hit make default and hit OK. Now when you go to calculate, for number 17, we're doing the inverse cosine of 0.468. So there's a trig button on the Inspire, and we want the inverse cosine. So we'll hit enter, and then plug in 0.468, and hit enter. So for this one, we end up getting 1.0838.
Are we allowed to round?
You want to have 4 decimal places, please.
Alright.
Number 18, you're going to plug in exactly as it appears there. You'll hit your trig button, inverse sine, go back to the trig button, go to cosine, and then on the Inspire it has the nice fraction key, and you can type in 2/3 and hit enter. And you're going to get 0.9041. Number 19. Again, you're going to go to your trig key, tangent first, put the inverse cosine inside of that, and then again the fraction key with 4/7 and hit enter. So we get 1.4361. And then our last one we're gonna go inverse sine of the cosine, and again entering the fraction, 7/3. We get negative 0.7625. So again, those last four are just plugging them into your calculator. And we're done.
Oh, yeah.